Hello everyone and welcome to my channel. Today we will talk about strings in Go. We will see how to declare string variables and what operations we can perform on them. Let's see now what strings are and how we can declare them. The Go programming language has native support for Unicode strings, encoded using UTF-8 character encoding, as we saw in my previous video, using runes. This means that string constants and identifiers can contain any Unicode character without special escaping or encoding. Strings are just an immutable sequences of bytes. There are two ways to declare strings in Go, using double quotes or using back quotes or backticks. When using double quotes, we are creating an interpreted string literal, and inside of double quotes we can use escape sequences. In my previous video, we already saw \n, a new line character. We also have \t for tab, double backslash for backslash, etc. When using backticks, we create a raw literal string. Inside it, we cannot use any escape characters. Let's open our code editor and declare a variable TV show to be the type of string and see its zero value and type. We can see that the zero value is an empty string and its type is a string. We can use the %q format verb to print an empty string. What this will do for us is to escape safely double quotes. Next, we will create two string variables. For the first one, we will use double quotes, and for the second one, we will use backticks. In our first string literal, we are using \t for tab and \n for the new line. And for the second one, where we use raw literal string, we don't need to use escaping sequences. We can see that with backticks we can create multi-line strings, so usually we will use them when we need to create HTML templates, JSON literals, etc. For everything else, use double quotes. We saw the same results for both strings when we run the program. What operations can we perform with our string? We can use all comparison operators to compare two strings. When comparing two strings, Go uses a lexicographical comparison. In computer science, lexicographical order is how words are alphabetically ordered based on how they are spelled. This is also known as dictionary order. They are compared from left to right, character by character. The string with a smaller character at the first position, where there is a difference, is considered less than the other string. For example, apple would be less than bear, because A is before B in the alphabet. But also, an apple with an uppercase L is less than a lowercase apple. So we will compare letter by letter from left to right. We can see here that the first three letters are the same, but the fourth is not the same. Uppercase L is less than lowercase l. We now know that the capital letters come before lowercase letters. And if we have a digit in a string, for example, app1e, it is less than apple with uppercase L. In this example here, we can see that the numbers come before uppercase letters. So the order of precedence here is first digits, then uppercase, and at the end lowercase letters. Also, in this example here, where we have an apple compared with apples, we can see that if both strings compare equal until one ends, the shorter string is lexicographically less than the longer one. Let's return to our code editor and see those examples in action. When we run the program, we can see that all 4 statements are true. So when we want to check for lexicographical order, we can use less than or equal to, greater than or equal to comparison operators. And to check if 2 strings are equal or not, we can use equal or not equal comparison operators. Let's assign the value of good doctor to our TV show variable. Let's introduce another variable, my favorite TV show, to be also good doctor, and check for equality. When we run the program, we can see is this my favorite TV show true. Before we continue to the next operation, I want to return to printf quickly and explain the difference between %s and %q format verbs. As we already saw, %q will escape double quotes, and when we use %s, it will print a string without quotes. Let's see an example here. We have 2 printf functions, one with %q and one with %s format verb. Let's run the program and see the output. We can see that the first one has double quotes and the second one using %s doesn't. We can access arguments in the printf function by location. Let's see what I mean by this. We have printf function with the format string, the value of TV show is %q and its type is %T. And then we have 2 TV show arguments. What we can do here is to remove one TV show argument and then in brackets in front of the format verb character put the number of argument position. The argument position starts with 1. We can see the same result for both printf functions when running the program. So to make it clear, let's see another example with 2 different arguments. Here we can see that we used 2 arguments in 3 places. When we run the program now, we can see that my favorite color is blue, my favorite food is pizza, and the sky is blue. This is how we can access arguments by location. Let's continue with our string operations. We can also concatenate 2 strings using the plus operator. When we run the program now, we can see my favorite TV show is Good Doctor. We can access a single string character using the bracket notation. Strings have a 0-based index, so if we want to get the first letter of our TV show variable, we will use this syntax. TV show, open bracket, 0, closed brackets. When we print its value, we can see that it's a 71, and its type is uint8, which is a byte. So we can see that using index operator on the string will return a byte value, not a character, like in other languages. Also, Go strings are immutable, meaning we cannot change an individual character in a string variable, but we can reassign its value. So if I try to change the value of the first character from G to B, we will get an error. Let's try to run the program. We can see the error message here, but it is possible to reassign the TV show value to another value, for example, the Lord of the Rings. When we run the program now, we can see that my favorite TV show is The Lord of the Rings. Let's define a new song string variable and initialize it to what does the fox say. We can check the length of it using the len function. If I run the program now, we will see that the length of the song string is 22. Let's use some emojis in our string. If we declare a new variable, song2, and assign the string value of what does the fox say, instead of the word fox, we use the fox emoji, what will the length of our string be? If you said 23, you would be right. It may be better to see this as an isolated example. Here we can check the length of the fox string and fox face emoji. We can see that it prints 3 and 4. But obviously we have only one emoji. This means that the len function returns bytes and not the number of characters like in other languages. You may now ask yourself, okay Zoran, but how can I count characters and not bytes? This is where the UTF-8 package and its RuneCountInString function come to the rescue. As we can see in the documentation, the RuneCountInString accepts a string as an argument and returns an integer, the number of characters, runes in a string. Also, here we can open and see some examples, and the cool feature here is that we can edit this example and run it inside a browser. Let's return to our code editor and print two statements using printl functions, both using UTF-8 RuneCountInString functions to print the length of song2, fox string and fox face emoji. We can see now when we run the program we have 20 characters in the song2 string, and also we can see that instead of 4 bytes we now have one rune for the fox face emoji. Here is the first assignment for you. Declare two variables, first name and last name, and initialize them to your first and last names. Then define a third variable, full name, that will be the concatenated string of first name and last name. And in the end, print a message, I am your full name, and my favorite emoji is emoji here, using the fmt printf function. The second assignment, print this message to the console using the printf function and double quotes, string literal. So the output should be on Windows in double quotes, go path is quotes C column \users your profile name \go. Use Windows as an argument for the printf function. In this video we saw what strings are, how can we declare and use them, how can we compare two strings and concatenate them using the plus operator. We saw that strings in Go are immutable sequences of bytes. Strings in Go are Unicode out of the box. We learned how to use the len function to check the length of the string. Also, we saw that len returns a number of bytes, and if we want to check the number of characters in a string, we need to use the RuneCountInString function from the UTF package. We saw how to use escape sequence characters in our string literals using the \. Also, we learned more format verbs we can use with the printf function and how to access arguments by location. Remember to check the link to my GitHub page in the description to download the code and do the assignments. Also, you can find solutions to them in the solution folder. I hope you enjoyed this video. Until the next time, bye!